Hi everyone, this is me Vijay Kumar, Assistant Professor, Department of Electrical and Electronics Engineering. Today we will see about the basic concepts of current. So I know many people are confused to that what is meant by current, what is meant by voltage, what is meant by power. We will take a small scenario. For example, in our household appliances suddenly stops all those working conditions means many people are saying that it is a current off. No, it's not a current off, it is a power cut. So our power, absence of power. So we need to make a awareness between voltage and then power and then current. So first we will see the definition of current. So current is a flow of electric charge such as electrons moving through a wire. It is measured in ampere and it has a direction. A current source is 5 ampere transports 5 coulombs of charge per second. So this is called as a current. So I will explain in small scenario. So just we are assuming that we are taking a one sources here. So I will make a small simulation here. So I will take a one voltage source. So here 1 volt, and then after that I am adding one switches or on ammeter. So because I know how much amount of current is moving, so that's why I'm making a say one ammeter here. And also I'm making a one switch. So this switch will help either I'm going to switch on the circuit or not. So this kind of things. So this will make a simulation stand here. And then after that I am taking a one load. So here I am taking a one kind of lamp load. So I don't want motor load, so I will delete it. And then I am taking a one lamp load here. So again I'm connecting here, and also one ground wire. So the ground wire is for a safety purpose. I'm connecting here, and then next the circuit will be closed. So next I'm going to make a some kind of detailing model. So that's why, so this voltage source will be 1 volt. So for theoretical purpose I'm taking as a 1 volt in simulation manner. Okay, and then we have in a one switch, and then ammeter. So ammeter, no need to calculate any kind of terminologies. So because the ammeter will show the how much amount of current will move from one direction to another direction or a source to load. So here this is the lamp load. So lamp load we are considering it, this is the 1 volt lamp load. Okay, so because the light is also one, supply is also 1 volt, so the lamp should be a 1 volt. Okay, the power, so we are calculating the power. So just example we are taking as a 30 milliwatts power rating. Okay, no issues. So I will take it as a 50 milliwatts. So here 50 milliwatts and then 1 volt power supply. Okay, next I'm going to simulate here. So just see the circuit. So there is no closed circuit here. I need to close the switch. Automatically the lamp will starts to glowing. And also calculate the current value. 50 milliampere current it is taking in this load. Okay, so I will explain how this is taking. Okay, so for example, in this circuit, what is the power value? Power value P equal to 50 milliwatts of lamp. Okay, and then what is the voltage value? The voltage value equal to 1 volt. So I need to calculate the current value I equal to P by V, that is the power by voltage. So the power equal to 50 milliwatts divided by 1 volt. So the current value equal to 50 milliampere. Okay, so this is the thing we are calculating the current value. Again I will explain the next scenario. So just I am taking this, I am going to change the load wattage. So here the 50 milliwatts, I am changing here 50 milliwatts to 20 milliwatts, right? I am going to reduce the wattage of lamp. Okay, now see the current flow. In earlier circuit the current flow movement is very fast, so here the current movement is very slow, and also here denoted as a 20 milliampere hour. Okay, so why we are going to take as a 20 milliampere current? So first case 1, the power P equal to 50 milliwatts. Case 2, power equal to 20 milliwatts. So here voltage value equal to 1 volt. So in this case also voltage value equal to 1 volt. Okay, so there is no changing here. The current value P equal to V into I. So this is the power calculation. P equal to V into I. I value equal to P by V, and also here I value equal to P by V. So I value equal to P 50 milliwatts divided by 1 volt. Here I equal to 20 milliwatts divided by 1 volt. So I equal to 50 milliampere. Here I equal to 20 milliampere. So see here. So in this condition, I am not changing the value of power supply, right? So because the power supply is same, the same 1 volt power supply, and also I am not changing the ammeter 20 milliamps. So this is the ammeter is the common thing. It is a measuring instrument. It is going to measure the ampere rating. Okay, and also I'm not changing the ground. So only I am changing this load segment. So the load segment is going to change. So that's why the current value in first case, the load taking 50 milliamps, second case the load taking 20 milliamps. Otherwise we can say as first case the source will delivered only 50 milliamps, second case the source will delivered only milliamps. So what we are going to say that in current value or a current moving the segment, so it is not depends upon the source, it is depends upon the load. If the load changes, automatically the current value will get change. Okay sir, how the current is changing, how the current is moving from one direction to another direction, we will see one by one. For example, what is meant by current? We should understand the concepts of current and then electrons and then free electrons. So we know the atom, all right? So in then each and every atom we have a outermost orbital electrons. So in this electrons is moving from one portion to another portion, or a one direction to another direction, or a one point to another point. So this is called as a current flow or a current movement here. So the how the current is moving. So just imagine this is the electron atom and then outermost orbital, again outermost orbital, we have in a free electron here, and also another one, again in here a free electron. So likewise in each and every conductor the bonding is continuous here. So again the last one outermost orbital here. So just one electron moving from the load, automatically in this area it is created as a holes. So in order to fill this hole, this electron is jumping to one direction to another direction. Again, another electron will jumping here. So automatically this process will continues from one person to another person. So this is how the current is moving. Okay. So I hope you people are understanding what is the current and how the current is going to be moved from one direction to another direction, and then what decides current flow or what decides the current segments, and then all those things is based on the load conditions. Okay, so I think you hope you people are